In this video, I will be explaining and showing you the major organic functional groups. I'll give you a couple examples of molecules that have those functional groups, and I'll also help you to identify if a molecule has that functional group. Now you know there are millions of organic molecules. It would be pretty difficult to have to try to remember what they all are and what they do. So lucky enough, we can use functional groups to help classify molecules. Now, molecules may have one or two or three or more different functional groups on them. A functional group is a cluster of atoms that helps us predict the properties of that molecule or that piece of the molecule. So these clusters of atoms behave in a certain way and have a certain function. And we'll go through these major functional groups and I'll show you what the clusters of atoms look like. So there are two main classes of organic functional groups. The first one is hydrocarbons. The second class is hydrocarbon derivatives. So we will go through the first class of organic functional groups first, and those are the hydrocarbons. There are two major categories of hydrocarbons: saturated hydrocarbons, which contain only carbon-carbon single bonds, and unsaturated hydrocarbons, which contain double and triple bonds between carbon atoms. Now, the reason they're called saturated and unsaturated is because when they're saturated with hydrogen. They're saturated with enough hydrogen to make sure that all of the carbons have 4 bonds. If they're unsaturated, that means there's room to put more hydrogen in the molecule because carbons are double bonded or triple bonded to each other. So let's start with the saturated hydrocarbons, which are alkanes. Some examples of alkanes are methane, butane, propane, anything that basically ends in ane. You can identify if you have an alkane because the molecule will have carbon-carbon single bonds. Now there's a derivative of alkanes that contain halogens. These are called haloalkanes. One thing I want to point out about this molecule is it looks like Rx. Now, we don't see any carbons, we don't see any hydrogens, we don't even see any halogens on this molecule. The reason is because oftentimes X is used to represent a halogen. So X can represent fluorine or chlorine or bromine or an iodine atom. So just know that from now on, if you see X, it is going to represent an atom of a halogen. Now this R thing, you're going to see a lot of the R thing. And the reason is because functional groups are often the areas of interest of the molecule. So if a scientist is examining a molecule, it's probably most interested in the functional group, which means that the rest of the molecule is not really that important. So the R stands for the rest of the molecule. Now we're going to jump to the unsaturated hydrocarbons. There are 3 major types of unsaturated hydrocarbons: alkenes, aromatics, and alkynes. Alkenes are easy to identify because you'll see a carbon-carbon double bond. One example of a molecule that contains the alkene functional group is retinal. Retinal is the molecule responsible for detecting light in our eyes. Aromatics are another very large class of unsaturated hydrocarbon. You can identify an aromatic because it's a 6-carboned ring. Now, it's not just a 6-carboned ring that contains single bonds. It's a 6-carboned ring that contains every other bond as a double bond. Now, in reality, those double bonds consist of electrons that are not stationary. So those double bonds don't exist in permanent places, but rather those electrons are evenly distributed around that 6-membered carbon ring. An example of an aromatic molecule is vanillin, which is the molecule responsible for giving vanilla its flavor. The final unsaturated hydrocarbon is an alkyne. An example of an alkyne is acetylene, which is used in welding. We can easily identify alkynes because they contain carbon-carbon triple bonds. Now we're going to go over to the hydrocarbon derivatives. There are 2 major classes of hydrocarbon derivatives: those that contain oxygen and those that contain nitrogen. So we'll start with the ones that contain oxygen. We have alcohols, ethers, aldehydes, ketones, carboxylic acids, and esters. So we'll go through each one individually. Alcohols can easily be identified because you have an OH branch on a molecule. So any sort of molecule that has an OH branch has an alcohol functional group. So usually when we refer to alcohol, we are talking about ethanol. But there are many, many, many different types of alcohols. Even glucose has that alcohol functional group multiple times on its molecule. Menthol is another example of a molecule that has that alcohol functional group. Menthol can be found in mint leaves. Now we have a derivative of the alcohol, and that is a phenol. An example of a phenol is the vitamin E molecule. Now I want you to imagine you take an aromatic ring and you put an OH group on it. That gives you the base group of the phenol. Now let's look at ethers. Ethers can easily be identified because you have a carbon branch on the left, a carbon branch on the right, and an oxygen in the middle. There are several different ethers in anesthesia that's used if you undergo surgery. The next hydrocarbon derivative that contains oxygen is an aldehyde. We can identify aldehyde molecules because they contain carbon-oxygen double bonds. On one side of the carbon you have the rest of the molecule, and on the other side of the carbon you have a hydrogen atom. Aldehydes are terminal functional groups, meaning they happen at the end of molecules because you can't branch anything off of a hydrogen. An example of an aldehyde is the molecule that gives cinnamon its flavor, which is called cinnamaldehyde. Another hydrocarbon derivative that contains oxygen is a ketone. The molecule responsible for giving butter its flavor is a ketone. You can easily identify the ketone functional group because you'll have 3 carbons in a row, and on the middle carbon you'll have a carbon-oxygen double bond. Now we have carboxylic acids. You can easily identify the carboxylic acid functional group because you have a carbon double bonded with an oxygen. On one side of the carbon you have the rest of the molecule, and on the other side of the carbon you have to have an OH group. An example of a carboxylic acid is acetic acid, which is the primary component in vinegar. The last hydrocarbon derivative that contains oxygen is an ester. Esters are what give fruits their wonderful flavors and smells. You can easily identify the ester functional group by looking for a carbon-oxygen double bond. On one side of the carbon that's double bonded in the oxygen, you will have the rest of the molecule. On the other side, you'll have an oxygen, and then after that, another carbon branch or the rest of the molecule. Now let's go to hydrocarbon derivatives that contain nitrogen. There are 2 of these, amines and amides. You can identify the amine functional group by looking for nitrogen bonded to hydrogens on one side and nitrogen bonded to carbon on the other side. Adrenaline is a molecule that contains the amine functional group. The final functional group that we will be going over is amides. You can identify an amide functional group by a carbon double bonded with an oxygen. Attached to one side of the carbon is the rest of the molecule, and attached to the other side of the carbon is NH2. Caffeine contains both the amine and amide functional group.